Hello, in this video we'll discuss about count set bit problem. What is count set bit problem? You are given a number and in that number you have to find how many bits are set, right? How many bits are actually high. For example, you are given a number 5 whose binary representation is 101. So you'll basically count how many bits are high. So there are 2 bits that are high, so my output would be 2. If we take another example, 8, its binary representation would be 1000, and the number of set bits or number of bits that are high are only 1, so my output would be 1. So I would recommend you to pause this video and try to make a solution on your own. Okay, so let's start to discuss this problem. In this video, I'll be discussing the most efficient way to solve this problem. So prior to that, let's discuss a fact about binary numbers. So I'll write binary representation of numbers from 0 to 10 to understand it better. Okay, let's do it till 8 now. So I would request you to notice a relation, try to notice a relation between two consecutive numbers, n and n minus 1. So let me discuss it now. The relation between n and n minus 1 is quite noticeable, right? If you start from the least significant bit, that the rightmost bit, this one, in every number the rightmost bit, and go till the rightmost set bit, this bit. And in this number the rightmost set bit is this bit, and this number the rightmost set bit is this bit. So if you go from the rightmost bit to the rightmost set bit, then if you complement or invert those bit, then you will get the n minus 1, the minus 1 of that number, right? For example, let's take 6, and I'm going from the rightmost bit to rightmost set bit, and I am complementing those bits. So from 0 to I have written 1, from 1 to I have written 0, and rest of the bits are same. Then I get minus 1 of that number. So this fact was quite noticeable. So how can we use this fact to solve our problem? How can we use this fact to count the set bits of a number given n? So it's quite simple though. For example, given input number is 6. So what I can do in this number is let me write the n minus 1 of this, that is 5 1 0 1. So if you notice, for any number n, if I AND with n minus 1 of that number, then I set the rightmost set bit to low. What would be the AND logical AND of these two numbers, n and n minus 1, where n is 6? The the result would be 1 0 0. So what did I basically did? I inverted or I inverted the rightmost set bit of this number n by ANDing it with n minus 1. You can see I inverted the rightmost set bit, right? So this is the key. Basically, this is the logic which we are going to use to solve this problem, count set bit problem. So if I do this every time and I count the times until my the answer is becoming 0, so the count would be the basically would be the my answer. So for example, I did um, and with minus 1 of the given number 6, and I got this as an answer, and I again if and I counted it, the number of operation that I did are 1. So this result is not 0 until till now. So I'll again and it with minus 1 of this number. So uh, what is this number is actually 4, and if I AND it with 3, what would I be doing? I would be inverting the rightmost set bit. That is, rightmost set bit is the only set bit in this number 4, and I would be inverting this only set bit, that is the rightmost set bit of this number. So you can see if I AND both of these number 4 and 3, I would get 0. And I did two AND operations, so I make my count to be 2, and I further do not do any on AND operations because I have attained a 0 number here. So my answer is 2. So basically what I'm doing in this solution is that for if the number contains like any set bits, like this number contains 3 set bits, then I'll be uh, for every in every iteration of the loop which I'll make in coding part, I'll be inverting the rightmost set bit of this number. So how much time my loop will run? It would actually run 3 times, right? Because the number of set bits in this number are only 3. So uh, for every iteration of that loop, I'll increment the count, and at the end I would get the count to be 3. So okay, thank you guys.